morning, everyone. My name is Madhukar, and I am part engineer and part growth engineer. So today I'm going to talk about multi-agent software engineering or multi-agent RAG systems, MARS for short. And we'll also talk about how you build an enterprise AI-based application using this architecture. This is something that we have worked with AWS very closely, especially with Bedrock. So we'll talk a little bit about an actual system that we have built out with a reference architecture that anybody can then go in and start off as a starter. So I'm going to talk a little bit about what is SingleStore or who is SingleStore in case you have never heard of us, which is quite likely because earlier we were known as MemSQL, and we have been around for a while. So we had a rebranding about four and a half years ago. We'll talk about naive RAG or simple RAG or retrieval-augmented system. Then we'll talk about what are the requirements for enterprise RAG. That's based on our experience of what we have seen working with very large companies doing RAG now and have either been in production or they're about to go into production. And then we'll talk about how we put this all together in a reference architecture with an application and a demo. So for those who don't know, the way I describe SingleStore is if you think about a transactional database, like a MongoDB, MySQL, Postgres, they are more for transactional, so point, read, and write. But if you're trying to run analytics, you take the data and then you move to something like a Snowflake, Databricks, Hadoop, or something like that, which is OLAP. So think of SingleStore as a hybrid database that can do both transactions as well as analytics, and it can do across petabytes of data in a few milliseconds. The reason why we are able to do that is because of the patented architecture. It goes from memory first to local disks, and then finally to object store. And the second thing that is different is that when data comes in, we store it both in row-based as well as columnar-based. So a lot of the use cases around real-time UI has become very topical. In addition, we support all the data types except for graph, and that includes the Mongo API as well. So I'll skip through how we came into being. Happy to talk more about it if you're interested, but this shows the journey of where we started, where we are today. We've been here doing this for the last 11 years, and we were one of the first to actually add vectors into our database back in 2017 when people didn't know about vectors, and the first paper on attention is all you need was released. Now, subsequently, of course, we did a bunch of other things. We have added ANN, we have added cloud-based, on-prem, hybrid as well. So in terms of, let's switch over to RAG. When the OpenAI and ChatGPT moment happened, of course, everybody realized that the large language models, they don't really necessarily know about the company data. So what you would end up doing is you would prompt the large language model by first searching your data, and that's why it's called Retrieval-Augmented Generation. In fact, initially we were calling it context learning or in-context learning, but later on the RAG term caught on because of a paper that was written by Meta. And typically, because of the transformer architecture or the transformer model, semantic search had a renaissance in the sense now people realize that if you have very large amounts of structured data, or sorry, unstructured data, which is, it could be audio, video, text, PDFs, files, or even PowerPoints, then you chunk them into vectors, which is basically floating points, and then you do some sort of either a dot product or you do cosine similarity to figure out the distance between the objects, and then come back and say, yeah, it looks like you're talking about canine, but that's also a dog, which is also Alaskan Husky, which is very, very different from an exact keyword search. So there was an entire resurgence of a new kind of databases called vector databases. So both in open source as well as in commercial, you started to see Zilliz, Milvus, VV8, Pinecone. Everybody came around, and they were primarily around vectors and vector databases. But people start to realize when we are working with companies that your AI system or whatever services you're building is as good as your data because everybody has access to the same large language models. And now you have Ensemble, plus you can do fine tuning as well. But to take that data, which is across petabytes, really requires both ETL or extract, transform, load. It also requires parsing that data continuously, then chunking it. And there are several different strategies for chunking the data. You need some sort of an embedding model to convert them into vectors or embeddings. And then you need to index them as well. And then after the indexing, you are then doing some sort of an ANN or exact KNN search, which gives you the similarities in terms of rank. So obviously, when this started to get into what I would call the enterprises, there were other big requirements that enterprises have, which is, hey, before I open my chatbot to the employees, I want to know that they are not asking about the weather in New York, because that they can do somewhere else. It's specific to the enterprise. Plus, I don't want any sort of inappropriate questions or answers going back. So there was input and output validation. Then the second thing that came in was, wait a minute, this came to me about 6 or 7 months ago when I was talking to a customer, and they were like, everybody's talking about vectors, but guess what? 90% of my data is actually sitting in SQL database, or it's in structured format. And we have data analysts who have written 16 pages long of SQL statements. How do you expect a large language model to just deterministically just run that or generate that SQL on the fly and be able to give me that answer, the same accurate answer over a period of time? So you need to do hybrid searches. Then you need guardrails. And guardrails, there's a really good library by NVIDIA. It's called NEMO. And NEMO guardrails has been in use now for over, I think, about 15, 16 months. And it's a very standard thing to now apply for RAG. Then if you're doing dot product or cosine similarity, then the results that get back comes back with some sort of ranking. So just to know that you're accurately responding or giving the right context to your LLM, you need to also look at the ranking. And then maybe you do some re-ranking by a few shot prompting based on questions that you continue to ask from the user. And then finally, you're doing evaluations. Evaluations are about, did I get the right question? Was it accurate? Was it appropriate? And if it is, then you feed it back to your maybe fine-tuning of your existing large language model that you might be using. So when it comes to enterprise requirement, it really falls under 4 different things, which is speed, accuracy, scale, and security. So when it comes to speed, you can think about it, of course, OpenAI released the OpenAI real-time APIs, where now you go straight from speech to getting an embedding, getting the answer in less than a second. And this is one of the enabling features for AGI, because if you want to be able to have a natural conversation with services, you need to have less than a second response times. But now if you're building enterprise RAG, you need to match that millisecond with your retrieval of the data, which the large language model doesn't know about. So now you have not only the advanced RAG, but you need to do that at the same scale and the same speed and the same accuracy that your enterprise is known for. So there are multiple different ways to think through it, like how do I take a response or a query, parallelize the operations? How do I take a few shot prompting and convert that again into different parallel processes? And how do I cut the round trip to one single query where I'm doing both analytics, I'm doing transactional, I'm doing aggregate functions, all in single shot or in one round trip? Similarly, when it comes to accuracy, if you have a Kafka stream of real-time data coming, which is a lot of companies that they do, you want to make sure that that data is represented, because you don't want to give stale data. If I'm doing something like a real-time investment, and now I give a response 4 or 5 seconds later, when a second or 2 seconds earlier the market suddenly changed, then that's not only harmful, it actually leads to revenue losses. So there are some industries, especially around healthcare, financial services, where the tolerance of accuracy is near 0. And then finally, how do you do more deterministic results and continuous evaluation? Deterministic means I don't want to rely on the large language model to take text and convert to SQL, because even after last 12 or 15 months of several advancements, the text to SQL is still roughly about 30 to 40% accurate. And it hasn't, of course, it's getting better, but you cannot rely on very complex SQL. So you have these functions, which could be your deterministic SQL queries or hybrid queries, but each time you call them as a tool or as a function, which leads us to what we'll talk about, and that would be agents. Then, of course, scale. You have your Mongo, MySQL, Postgres, but you also have data lakehouses. You might have Hadoop. You have file systems. And now we are talking about, not a few terabytes. We're talking about 10 petabytes of data. And it gets bigger and bigger because you're getting Kafka and other streaming data poured into that as well. So now imagine if you want to do all of this and you also want to make sure that you have security. So you need to have RBAC, or you need to have row-level RBAC. You need to have also the ability for explainability. You need to have auditability. You need to have guardrails. These are all enterprise requirements, and this is just table stakes. And finally, if you now combine it into what is called the advanced RAG, you see all the data sources on the right-hand side, which is, or at least my right-hand side, which is the file system, unstructured, all the different file types. You might have JSON, because that's your transactional. You might have data lakehouses, and there's this huge disruption going on there with Iceberg. And then you have SQL data, and that SQL data could have different dialects. Now you merge all of that into what is called a contextualized layer, where you're doing a single shot or one round trip query, and you get back all of that data in less than a millisecond or less than a second. So when you put it all together, this is the evolving architecture that we have seen, where on the right-hand side, it's your contextual layer. You have data ingress, and you are doing it in a zero ETL manner. And on the left-hand side is your framework. This is where you have Bedrock. This is where you would get LangChain or Llama Index, or we'll also talk about maybe the LangGraph that LangChain came out with. And then, of course, on the top, you have the interface layer, which could be conversational, plugins, and so on. Now, if you take a step back and say, okay, if we were to architect this, let's first look at how software engineering has evolved. And you would see that even from a monolithic system, we went to a modular system, and this was personified in microservices and object-oriented programming, and so on. And similarly, in RAG, when we started off, it was all monolithic. You would do the entire RAG in one single file. I have done that as well. But you realize that's not scalable. You cannot maintain it. The exact same problems that you had earlier. So then came agents. And agents were like, OK, you know what? We can take the individual items that you do for RAG, and we convert that into an agent. And then we take that agent and we orchestrate it. But when you orchestrate it, the first evolution of this architecture was around creating a supervisory agent, which then breaks down the task and decides which agent gets whatever task. Now, that is all great, but what is an agent, right? So if you break it down, an agent really, in my mind, comes down to three things. It has access to intelligence, which is a large language model. And that large language model could be, in fact, a small model. It could be a fine-tuned open source model, and it could be specific to a domain. Second, it has memory and knowledge, which converts to data. So it has access to all your data, structured and unstructured, but it also remembers your session over a period of different interactions. And finally, it has tools, which is basically APIs. So multi-agent RAG systems, now think of all the RAG that tasks that we have converted into separate agents. But you still don't want to run it through a supervisory agent because it's very non-deterministic. Now the supervisory agent decides which task goes somewhere else. So you want to orchestrate this in a workflow which is the same and has the if-then loop and the while loop, which is where the graphs come in. So now AWS Bedrock has this notion of an agent where you can actually not only create the agent in this architecture that we have defined, but you can do that in a deterministic workflow. And then you have the same system with SingleStore on the right-hand side, which is your contextual layer. Now I put all of this together. And with this, I'll skip this because you can go to our site and you can read more about this. Now we take all of this and you build out an actual system. So we ended up building a system with Bedrock and SingleStore that is an advanced co-pilot customer support agent. So for that, let me invite Swati Choksi. She is the leader of solution architecture team at AWS, and she's going to talk about how she built this entire, or her team built this entire application using this architecture. Thank you, Swati.
I need to go back. Well, thank you. Thank you, Madhukar. So Madhukar just said, I run the solutions architecture team at AWS. And as part of our charter, we actually help our customers build on AWS. And we recently announced a strategic alliance with SingleStore with a goal in mind that we want to give our customers end-to-end tools which allows the customer to build their data foundation using SingleStore, and they build performant and secure applications that are also responsible using AWS's GenAI stack. So let me talk a little bit about the GenAI stack. So it is a 3-tier stack, where at the bottom of the tier, you have all the tools that you need, even if you want to build your own FM. So we have our custom chips, and we have our SageMaker. So along with that, we also have petabyte scale networking capabilities, and we have hyperscale clustering. And with that, the Trainium and Inferentia chips are actually designed for GenAI workloads. And SageMaker offers you a number of different FMs to choose from. And the idea is that when it comes to use cases, it's never one size fits all. So you have a choice of models, and then you have the tools that help you actually fine-tune these models. Now, if you look at the second layer, we have Amazon Bedrock, which is a fully managed service. And along with that, we have guardrails and agents, and we have so if you look at the Amazon Bedrock, we provide a choice of FM models. So these models are from companies like Cohere and Anthropic and AWS and Meta and many others. And along with that, we also have tools like you can use RAG, and you can use agents when you're trying to build something that is more complex, like when you're trying to let's say you're trying to build let's say have insurance claims processed, or you're trying to build marketing campaigns. So these are the complex tasks that you can build using agents. And all of these things you can do privately, because these models will not have access to your data. And we also provide guardrails. So all of us worry about actually building GenAI applications that are responsible. So what the guardrails do for you is they block 75% of the hallucination and 85% of the harmful content. So if you look at like the top tier, the top layer of the stack, we have Amazon Q applications, and these Q applications are GenAI applications which are designed for various number of use cases and number of personas. So there is Q for business and Q for developer, Q for quick site. And important thing is, it offers 40 plus connectors. And these are the connectors to business apps that are used on daily basis. Like, you have Salesforce, and you have S3, and Gmail, and many others. Now, so a little bit about the agents. You can very easily build with AWS Tech Stack. You would choose your FM, and you would choose your knowledge base, and you would write up, you would write up quick code, and it's mostly no code type environment. And more importantly, it also gives you ability to given that it is fully managed, you don't have to manage the infrastructure either. And it gives you insight into FM's chain of thought. So therefore, it is, if you want to tweak your responses, you can. Similarly, when it goes to, when we talk about our knowledge bases similarly give you insight into, so it will give you, when it gives you the result, it's a fully managed rack flow. So, you don't really have to worry about, all your ingestion and retrieval as well as prompt augmentation. All of that is done in a rack flow. And with that, it gives you visibility into it gives you citations for your sources. And because of that, if you want to make any adjustment to your responses, you can. So with that, I want to show you a video. And this video is about one of our customers who built using SingleStore and AWS. And it is a video about how they build a customer service agent using our tech stack. So here we go.
Let's explore a simulated example that shows the power of Amazon Bedrock and SingleStore to transform customer service. Meet Sarah, an Iris phone user who loves her new AI assistant. However, she's noticed her battery is draining unusually fast. Frustrated, she reaches out to customer service for help. As Sarah's call connects, the AI-powered customer service system springs into action. The system, powered by Amazon Bedrock and SingleStore's real-time analytics, aggregates data from multiple sources to create a comprehensive customer profile within milliseconds. This information helps our customer service team provide a more personalized experience. As the conversation continues with Sarah, the Iris agent, our primary conversational AI, is analyzing the chat in real time. Built on Amazon Bedrock and armed with powerful tools, it's able to rapidly search through case histories to identify cases that match Sarah's issue, speeding up issue resolution. Starting from the knowledge base, the agent generates a personalized troubleshooting path based on Sarah's device profile and an initial assessment of her issue. This guide provides a customer service associate with a structured and efficient approach to addressing Sarah's problem. As the conversation unfolds, multiple AI agents collaborate seamlessly. The Iris agent understands context and intent. The diagnostic agent analyzes real-time data streams to identify the root cause of issues, while the platform agent focuses on a deeper analysis to uncover and address broader issues. This multi-agent approach, orchestrated by Amazon Bedrock, allows us to tackle the problem from multiple angles simultaneously. We're not just responding to Sarah's issue, we're investigating it in the context of our entire user base. The Iris agent notices a broader issue and pulls in the platform agent for further analysis in parallel, showcasing how our system can escalate problems to prevent larger scale issues. The diagnostic report generated evolves with live data, and using SingleStore's real-time analytics, we can instantly correlate this issue across millions of devices, generating a detailed impact analysis. Everything the Iris platform engineering team needs to make smarter decisions on what to do next. Transform customer service with real-time analytics and multi-agent generative AI for smarter, more personalized experiences.
All right, and I want to leave you with this. This is a QR code you can use to get discount. So please try it out. All right, thank you.